guys, welcome to Deep End, meaning with Chloe and Regina.
So Chloe, you're currently a deep learning engineer here at MDN. Could you tell us a little bit about the project you're doing and what you're working on?
What I'm currently working on is creating and simulating neural cellular automata. So what is that? They are computer models which have a grid of units, each representing a cell, and each of these cells has an update function, which we encode as a neural network, so it's trainable. And that update function, all it is it takes in an input, which is the current state of the cell, and gives an output, which is the state of the cell in like a second. And so what's really cool is that even though all of these cells update independently using the exact same update function, we're able to observe really complex, almost globally coordinated behavior. So complex, lifelike behavior emerge from just having enough cells on the grid, each updating independently. So this mimics biological systems, because what do biological systems contain? It contains cells which grow independently based on some update function. What is that update function? The DNA, which we instead use a neural network as. Even though the cells can't communicate between one another, they're able to form these complex life organisms. So how does it link to high performance computing? The system is inherently parallelizable. So we wrote compute shaders, which compile in the GPU and mean that we can execute the computation or the update for multiple cells in parallel, which gives us optimized rendering. It means we can render more beautiful animations,
Much more efficient.
yeah, which you can see on our website.
We'll put the website in the link below in the caption. But that's actually incredible. Chloe, you've done such amazing things with this project. Why do you enjoy working on Neural Cellular Automata?
I've stayed on this project for about a year now, so I must really like the team. And I do. I love my team. Shout out to the team, by the way. I think the problem we're solving is just inherently really interesting in general. Some of the things I enjoy about it are, first of all, because the model is so small scale, we're able to rapidly experiment. So I can tweak a loss function, which is what calculates the difference between the target we're training the model to reproduce and what the model is currently producing. So I can tweak how that loss is calculated, and then I can just retrain the model, and in a few minutes, I can evaluate what changes, I have brought about from tweaking that function. And I think what's unique about this type of machine learning too is that we don't have a massive data set. Like, we have one target image or voxel if we're working in 3D. And what really impacts the performance of the model is not the data that we train on, but how we train the model. So I think it's really rewarding because we get to play around with the model architecture, do a lot of machine learning things, and see the results of that rather than being bogged down with a lot of data processing.
Wow, that's incredible.